example number 3 of Riemann sums and how they relate to sigma notation. In this example, we are asked to approximate the area under the curve of y is equal to x squared on the closed interval 0 to 1 with a Riemann sum using 4 subintervals, in this case rectangles, and using the midpoints. So some of the important information we get is that we know that our f of x is going to be y equals x squared. We're working over a closed interval from 0 to 1, and we're using 4 subintervals. And the type of approximation we'll be using will be the midpoint. Our first step is to find delta x. So the width is going to be b minus a divided by n is equal to 0 minus 1 divided by 4. So the width of each interval is going to be 1/4. So starting at 0, we go from 0 to 0.25 or 1/4. Then from 1/4 we go to 1/2. And from 1/2 we go to 3/4. And from 3/4 we go to 1. However, notice we are using midpoints, which means we have to find the midpoint of each interval. So halfway between 0 and 1/4 is 1/8. And halfway between 1/4 and 1/2 is 3/8. And halfway between 1/2 and 3/4 is 5/8. And halfway between 3/4 and 1 is 7/8. Now we're going to find c sub I, given that the x values of the midpoints would be 0.125, which is the decimal equivalent of 1/8, right here, 0.375, which is the decimal equivalent of 3/8 over here, 0.625, which is the decimal equivalent to 5/8, and finally 0.875, which is the decimal equivalent of 7/8. Now, remember that c sub I is any interval, any point within the interval. In this case, it's the midpoint. So we want c sub I, the first one, to equal 1/8. We want the second one to equal 3/8, and so on. So the recursion formula that we come up with is 1/8 times 2i minus 1. Now, you may recall that 2 times any number is even, and we want the numerators to be odd. So we're going to subtract 1 to get the odd numbers in the numerator, 1, 3, 5, and 7. Let's explore that a little further. And you see I included a table. So when I is equal to 1, 2 times 1 is 2, minus 1 is 1. Multiplied by 1/8 gives us the fraction 1/8. When I is equal to 2, for the second subinterval, 2 times 2 is 4, minus 1 is 3. Multiply that by 1/8, we get our second midpoint, 3/8. When I is equal to 3, 2 times 3 is 6, minus 1 is 5. Multiply that by 1/8 gives us our third midpoint in the subinterval, 5/8. And then finally, when I is equal to 4, 2 times 4 is 8, minus 1 is 7. You multiply that by 1/8, it gives us the midpoint of our fourth interval, 7/8. So now we have the midpoint of each interval. To find the height of the rectangle, we're going to plug this recursion formula, 1/8 times 2i minus 1, into our original function squared, and that's why this is squared right here. So we have the width of each interval given by c, and the height given by f of ci. Our final step will be to create a summation where we multiply the area of each rectangle, which is going to be length times the height. The length and the height are going to be this. So the length of each subinterval is going to be 1/4, and the height will be the recursion 1/8 times 2i minus 1 squared. And you can see the arithmetic over here on the right-hand side. And when all is said and done, we're going to find out that the area under the curve is equal to 0.328 units squared.